All right, so these problems covered P1 and P2. P1 was like the quadratic, even root property, all that good stuff. And then P2 got into your inequalities. So P1, the first one, this is your rational equations. When you have variables in the denominator, obviously you're looking for the greatest common or least common denominator for all three. You first factor the bottom one on the right, which is x times x plus 3, and then list all of the terms that are there that are different. So I have an x to the first power, and then you've got x plus 3. Those are different expressions, so the combination of those is the least common denominator. If one of these was raised to the second power, so let's just say like this was squared, now my least common denominator is actually going to be an x times x plus 3 squared. So just keep that in mind. If there was 3 different expressions, if you had x and then x plus 5, x minus 5, then all 3 of those would be part of your least common denominator. So then we multiply the entire fraction by that least common denominator, and one at a time cancel out what would overlap. So if I multiply this times this fraction, the x's are going to cancel out, and I multiply this 6 times the x plus 3. If I multiply it by this fraction, the x plus 3 cancels out, and I get 2 times x. The negative came from the minus that was in between. And then when I multiply the last one by that, it's the same in the what I'm multiplying by, and the denominator cancels out. So I just keep the numerator, and I distributed 3 times x and then 3 times 5. And that's where you get that line. Distribute the 6 in, and I get 6x plus 18 minus 2x equals 3x plus 15. Combine your like terms. 4x plus 18 equals 3x plus 15. And then subtract the 3x and subtract the 18, and I get x equals negative 3. So now when you're dealing with rational equations or equations that have variables in the denominator, you've got to check to make sure that your answer is okay. It's not an extraneous root. So when you take those answers and you plug them back in, if at any point in any of those denominators it would be 0, you have to rule out that answer. Let's say there was 2. Let's say you had negative 3 and positive 3. You would cancel out the negative 3 and keep the positive 3, because the positive 3 would be fine in the bottom. However, this time I only have negative 3. If I plug negative 3 in here or in here, I end up getting 0 in the denominator. It happens just once. It means you rule it out. And in this case, there's no other solution, so there would be no solution to this answer or to this question. Questions on that one? Okay, second question was using the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. A is 16, b is negative 40, and c is 5. When you plug it in and you square the b and then subtract the product, you end up with 40 plus or minus the square root of 1280. That breaks down into 16 root 5. And then from there, you've got to break it down even further. You can either split it from here and then reduce it. So I could do 40 over 32 plus and minus 16 root 5 over 32 and reduce it from there. Or I just divided them all by 8 and I got to this step. And then you can split it. And when you split it, the 2 root 5 over 4 can be reduced further. So you want to make sure that if you can reduce any portion of that fraction, that you split it and reduce it. So you should get in 5/4 plus and minus root 5 over 2. Questions on that one? Okay, next one was an equation with a exponent, which is a fraction. So when you have fractional exponents, it's the same thing as if like it's a square root, right? So if it was 3 halves, this is the same thing as saying x plus 5 square rooted raised to the third power. So that 3 over 2, the 2 slides over to become the index, which is square root, and then the exponent would be from the numerator. But before you go to do any of that, you actually want to get rid of that exponent. The way you get rid of the exponent is to raise it to its reciprocal power. So I'd raise it to 2/3 on both sides. It's going to cancel this one here. And then I'd get 27 to the 2/3. So again, 27 2/3. The 3 slides over to become the index. So that's the cube root of 27. The exponent is now the numerator from my fraction. The cube root of 27 is 3. 3 to the second power is 9. And I get x plus 5 equals 9. Subtract the 5 from both sides, and I get x equals 4. There is technically a square root here, even though it's disguised as an exponent. So anything with a square root, you also need to check. You want to take this answer, you want to plug it back in. So that's what this work is. 4 plus 5 is 9. 9 to the 3 halves would be the square root of 9 cubed. 3 cubed is 27, and 27 equals 27, which is the right side of your equation, so you know it works. So the answer here is 4. Questions on those? Okay, then comes the inequalities. So this is now P2. The inequalities, when you're dealing with absolute value, you want to first get the absolute value on the side by itself. So I divided both sides by -2, and in doing so, it switches the sign that was greater than to now be less than. Then you have to, in your head, think that what that means, that absolute value of x minus 5 is less than 5. A less than becomes an and statement. I take the number that's there, I put the opposite of it on the left side, so that's -5. Keep the sign going in the same direction, so -5 is less than x minus 5, which is less than 5. And then add 5 to all 3 parts, and I get 0 is less than x, which is less than 10. On a number line, it looks like this. Less thans get parentheses, and if it's in between 0 and 10, I shade in between. Questions on that one? So let's just say that instead of it being less than here, let's say this was absolute value of x minus 5 is greater than 5. Remember, if it's greater, it becomes an or statement. So I would add the -5 on the other side still, but then I would split it into 2 separate statements. One where it's x plus or x minus 5 is less than -5, and minus 5 is, interesting, greater than 5. All right, so again, if once you got rid of the whatever's on the front of the absolute value, if it was less, if it's now a greater than statement, that becomes an or statement. These arrows would point out. So just be really careful. You don't want to switch those up. Less than and greater than or. Then we had the inequality with a quadratic. So these are the ones that if they're not already factored for you, you need to get everything to one side. So I move this 6 over. And that becomes x squared is less than, or sorry, x squared minus 5x minus 6 is greater than or equal to 0. And then I would factor it. So I'd get x minus 6 and x plus 1, set them each equal to 0 to get your 2 test points, which are 6 and -1. Set up your number line, which looks like this. Plug in points from each range. If I plug in something less than -1, like -2, it worked. This is greater than or equal to. 14 is greater than or equal to 6. If I plug in something in between -1 and 6, like 0, it does not work. 0 is not greater than or equal to 6. And then if I plug in something to the right of 6, like 7, it works because 14 is greater than or equal to 6. So then my solution sets comes from the outside. The arrow is pointing out. This is now or equal to, so it gets brackets. And I would say that x has to be less than or equal to -1 or greater than or equal to 6. Questions? Everybody good? Yes? Okay. Any questions on the P2 homework?